Okay. Okay, entonces we continue doing the conic sections. Conic section we study ellipse and parabola. Now hyperbola. Hyperbola is a little bit different. Hyperbola, we have two kinds of hyperbola. Look, let me show you. The theoretical part of the hyperbola. Hyperbola contains two branches, like that, or like that. Okay, I call this is like a horizontal, and it's a vertical. Actually, this is not a formal name. However, it's the nickname to identification this. So now the equation of the hyperbola is suppose x squared over a squared minus y squared over b squared equal 1. Y squared over a squared minus x squared over b squared equal 1. This is the confusing part, in my opinion. Okay, normally the habit can we have a, b, and c, and the ellipse is completely different to the hyperbola. Okay, and you identify who is a, and the term gets a positive part in the equation of the hyperbola is always a, not necessarily the big number. No. Okay, this is the part that's confusing for the students, no? So we have a and b. Okay, immediately I want to explain who is a, who is b, and who is c. Okay, so in the hyperbola we have, look, let me show you. We have one axis here. It's called transversal. Transversal axis. In this case, when the positive part is associated with the x, it's because the transversal axis is on the x-axis or at least parallel to the x-axis. Okay? However, do you see clear like water? If the positive part is associated with the y, so now the transversal axis is, in this case, is like that. Parallel or coincident with the y-axis. Okay? Entonces, the most important parameter is, okay, let me write now the equation for the hyperbola when the center, because we have center h comma k, no 0 comma 0. In this case, the center is at the point 0 comma 0, so h and k are 0. Suppose que no, que es different, h comma k, entonces es x minus h squared over a squared minus parenthesis y minus k squared over b squared equal 1. Likewise here, the other vertical hyperbola is y minus k squared divided by a squared minus x minus h squared over b squared equal 1. Okay, entonces es only subtracting h and k, and remember, it's important memory divide. Remember que h is associated with the x component and k is associated with the y component. But okay. This is no important, super important detail. The important detail is this. The central idea is this. Okay, first of all, you determine that our conic section, a hyperbola, when you have x squared and y squared expressing in the equation, but it's minus. Okay, remember, and the x squared and y squared, when it's plus, it's ellipse. No, this is hyperbola. And when you have x squared and y no squared, or y squared and x no squared, is parabola. So it's the way to identification, this conic section. Okay? Okay, entonces hyperbola minus, entonces how do you know the transversal axis? This important idea. Well, the positive part is associated with the x, the transversal axis is coincident or parallel. to the x-axis. Si the positive part is associated with the y, entonces the transversal axis is coincident or parallel to the y-axis. Entonces, the most important point when you are doing the graph of the hyperbola is okay, suppose que we have horizontal. Okay. Entonces, this is the center. Okay, in general, in this case 0,0, but in general is h, k. Okay, that distance, so that point, sorry, is the vertex. And the vertex is located at the distance 8 from the center. Okay, now C is the focal distance, as always, no? But be careful because the formula is completely different to the elixir. In elixir, do you remember that the big one is A? So A squared is equal to B squared plus C squared. This is elixir. But forget about elixir. No elixir anymore. A is ABC, but it's different relationship. Look, the relationship is C squared is equal A squared plus B squared. And C again is a focal distance. Que is the distance from the center to the foci, que the foci lie on the branch of the hyperbola, no? That distance is C. Now you can see clear that C is bigger than A. Okay? And what about B? Well, B you see in the equation. However, the idea for the B is, pay attention, que it's a little bit weird, complicated. Normally the books say that you are doing a famous reference rectangular. Look, we are doing rectangle like that. This rectangle is called reference. Reference rectangle. And the dimension for that rectangle is, well, this is obvious, it's A. Therefore, this is 2A, no? 2A. And vertical, and well, in this case, vertical is this distance B, and this is 2B. And you can find, why not, the four corners of the reference rectangle. And you are doing a connection, so the line connecting the corner. Look, I do using like a dotted line. And this line represents the slant asymptote of the hyperbola. So the hyperbola, the graph of the hyperbola, this is mandatory. So you are doing well. You are doing completed. The graph of the hyperbola, you need to represent vertex, foci, reference rectangle, the asymptote, and the equation of the asymptote in general is y is equal plus and minus, because we have two, no? One have positive slope and another have negative slope. In this case, B over A. Remember, this is distance B, this distance is A. So obvious que the slope, by definition, is the ratio between rise is vertical, wrong is horizontal, is B over A, X. Okay. This is in the case in which you suppose that the center of the hyperbola is the origin. See, it's not, entonces you change a little bit. It's y minus k is equal plus and minus b over 8 parentheses x minus h. But this is the equation and the analysis under the consideration that this is the horizontal hyperbola, no? And remember, horizontal hyperbola, I repeat again, the hyperbola que have the famous axis transversal, coincident or parallel to the x-axis. But in the scenario in which you have the vertical hyperbola, es the hyperbola que look like that, no? See? Well, this is the center again. In this case, I suppose 0, 0 or no. This distance is 8. And remember, the equation for this hyperbola look like that: y squared over a squared minus x squared over b squared equal 1. Now you take a, that number, in the positive part, and no in the negative. C is the formula, that formula. Same formula. C is that focal distance. This is C. This is C. Always the focus is inside, like a parabola, no? Similar. And now we are doing the famous reference rectangle, okay? In this case is like that, reference rectangle. The dimension of the reference rectangle, and this dimension is 2a. Here in this case 2b. And the corner of the reference rectangle, we connecting by the slant asymptote, que is important part of the graph of the hyperbola. And the equations for this line are asymptote, of course, is y equal, look, it's similar to this, but a little bit different because it's plus and minus a over b. And it's clear because the vertical distance is a and the horizontal distance is b. X. In the case, in the scenario, que the center is in 0,0, pero si the center is not in 0,0, the formula is y minus k equal plus and minus a over bx. Okay? So one detail, in this case, is easy to remember, que b over a, in this case, a over b. Do you understand very well this or no? A lot of detail is different to Elixir, totally different to the thinking we are learning so far. Of course, you see now several examples to understand much better. Any questions so far? So when you have equations, so normally the example, I give you the equation, no? Entonces, my question is, do the graph of the hyperbola, no? Okay, now you determine what kind of the hyperbola, si es horizontal or vertical. You determine the A and B and determine C using the formula. Okay, so you determine vertex, focus, reference rectangle, and determine the equation for the asymptote. It's a little bit more complicated because you have more detail, no? Any question? Ready to see example?
Yes.
Okay, super. Example 1 is always easy. Is x squared over 4 minus y squared over 9 equal 1. Entonces you immediately identify, wow, it's a hyperbola because it's both square, look, and minus in between. Super hyperbola. What kind of hyperbola? Is horizontal hyperbola or vertical hyperbola? Okay, the next question is vertical or horizontal? What do you think? In other words,
Horizontal.
How do you know que horizontal?
Because the x squared over 4 is positive.
Exactly. So now you see, the only detail that you see, what is the positive guy? This is the positive guy, es en X. Entonces, our transversal axis lie or parallel to the X axis. Entonces, my hyperbola open in that direction, horizontal. Very good. Okay, now, my next question. Where is located the center of this hyperbola? Center. At what point is center? No idea? Center? Remember, we have this equation. Okay. And we have this equation. And I can see that we have no H, we have no K. That means that the center is located at the origin, 0,0. Makes sense or no? Huh?
Yes.
Entonces, my question is, who is A squared and who is B squared? In this example. Who is A squared and who is B squared?
A squared is 4 and B squared is 9.
Exactly. A squared 4, B squared 9. Therefore, A is 2, square root 4, no? And B is 3. If you want to find the C, well, okay, the formula is C squared is equal to A squared plus B squared. Be careful. I repeat again the idea. The formula is different to the elixir. Because in this case, so you compare A, B, C. In this case, C is the bigger value. So C is equal to square root A squared plus B squared. That's the formula. And the square root 4 plus 9, 13. And this is irrational number, no? So you compute in the calculator approximately 3.606. Okay? Let's do in the graph. We use this easy example. A little bit behind, and immediately you see clear in GeoGebra. I suppose in GeoGebra, no, sorry, in Desmos. I suppose that you receive the script in the Desmos I create for you, right? To do the graph of the any conic section. Yes or no?
Yes.
Yes. Okay. You're using anytime. Okay. This is X. This is Y. This is the center. And that distance is 2. That 1, 2, 1, 2. It's a vertex. The vertex look at the point 2,0 and minus 2,0. Because I identify our famous transversal axis lie on x-axis. This is transversal axis. Therefore, my hyperbola open in that direction, no? Of course, I don't want to do here because I need to do more. I need to plot B. But to plot B is B3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Therefore, our famous reference rectangle look like that. Okay, and our famous slant asymptote is this and this. And this is important to do because when you are doing the graph of the hyperbola, okay, by the way, look like that, so passing through that point, and this is asymptotically to this. Approach it, but never touch. Okay. And finally, why not plot the foci? The foci is located at the point that distance, no? 3 point something, 3 point something. This is 2, this is 3, this is 4. 3 point approximate here is my first que es 3,606,0. And like y, this is -3, -4, approximately here. Is minus 3.606,0. And the story? No. Now the equation of this asymptote equation is y is equal plus and minus, because we have two, the positive slope and the negative slope. B over A. Who's B? I know B is 3 and A is 2. 3 over 2 x. This is the equation for the hour slant asymptote. Any question? Entonces now, this is the idea. The idea is do the graph in complete details. Detail means that you plot any points, center, vertex, rectangular reference, focus, y asymptote in the list. Okay? It's clear or no? Okay, let me try to see this job in Desmos. Guy, question. Switching. Desmos. Okay, we are doing the example number 1, hyperbola. Case this. Look, something like that. Oh, wow. But the details you see here. Well, in this example, A is 2, B is 3, H is 0, K is 0. And the classification is about the horizontal hyperbola. Boom. You see the job completed. You see the center, vertex, reference rectangle, every corner, equation for the asymptote and the fossil. End the story. Any question? Super good or no? Or confused? Coach, come on.
So far.
So far. Okay. Let's move on to the example 2. Example 2. Okay. Example 2, we have 16 y squared minus 9 x squared equal 144. And remember, in the test, I give you the equation of the conic section, not necessarily always in the standard form. You need to apply some algebra in order to express in a standard form. Remember, standard is that form. Y squared over a squared minus x squared over b squared equal 1. No? So it's important, extremely important, that the right-hand side of the equation is 1, not 144. Therefore, that indicates us that you divide the equation, the entire equation, by 144. Entonces you would divide 144 divided by 16 is 9. Entonces you put y squared over 9 minus, and likewise, this is 16 equal 1. Boom. And we have the equation exactly in this way. Standard. This is called a standard form. Okay? Now, I need help. What kind of hyperbola we have in that moment? We have horizontal hyperbola or we have vertical hyperbola? In other words, our transversal axis is coincident or parallel to the x or to the y? Come on, answer me.
Parallel to the y-axis.
How do you know?
Because y squared over 9 is positive.
Exactly. This is the idea. Now, This is the vertical hyperbola. Entonces, who is A square and who is B square? Who is A square? Who is B square?
A squared is 16, B squared is 9.
Are you Isabella, no?
Yes.
Isabella always know everything. Okay. Entonces, you say que A square is 9 and B square is 16. Therefore, A is 3 and B is 4. Okay, good. Now the roughly sketch without decimals. I suppose que my hyperbola, the center is in the origin, no? 0,0, no h, no k, no h, no k. And now the distance is a que 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. But in this case, it's on the y-axis because I know que our hyperbola open in that direction, right? Everyone understand this idea? Okay, entonces we are doing the famous reference rectangle. Is 4 and B, 1, 2, 3, 4, 1, 2, 3, 4. We are doing quickly this rectangle. Okay, we connecting the corner, and this is the asymptote, passing through the center. Okay. Okay. After we determine the equation for this. And our hyperbola passing through here and moving in that direction. Okay, I forgot determine C. But it's easy. The formula is C squared is equal to A squared plus B squared. Therefore, C alone is square root 3 plus 4. No, 3, no, 9. It's a square. 9 plus 16 is 25. And square root 25, 5. Oh, nice. The focal distance is C, is 5. Entonces, this is 3, 4, 5. Here, it's located my first foci, que es 0,5. I forgot to say, pero es obvio, ¿no? Que the vertex is 0,3. Another vertex is 0,-3. And the foci 1, 2, 5 here is 0,-5. And the equation of the asymptote is y equal plus or minus. In this case, is that distance, que that distance is A, divided by that distance, que es B. Entonces, A over B. The formula is A over B, no B over A, because this is the vertical asymptote. So A is 3 quarters, 3 over 4, 3 over 4, 3 over 4, x. Is the equation for that line. Asymptote 1 and asymptote 2. 1/2. What is 1? What is the 2? One of the positive slope. This is the positive slope, no? This is the positive slope, is this. And negative slope is this. Any question, guys? ¿Es easy o no? It's okay, Isabella?
Yes, it's okay.
And the rest of the students understand very well or no?
Yes.
Christy, Liz? Are you there or no? Helen? Marvin? Juan?
I'm here, Professor. Helen.
Helen, very well. And Christy and Liz, no? Sleeping.
Sí, profe, estoy aquí.
Ok, bueno. Viviana, Tinoco. Ok. Okay.
Hey, Profe, I'm here too.
Okay, I know. Okay, no problem. Okay, now let's go move on to the Desmos to see the example 2, no? Let me know if you see or no Desmos. Sorry. Do you see that? No? Yes or no? Isabela?
Yes.
Yes, we see it.
Okay, entonces let's move on to example. Example 2 is hyperbolic example 2, yeah. Is this? Wow, it's expecting. Look, it's the vertical. Now in this example, A was equal 3. I change this. B is 4. And again, the center is in 0,0. The H and K is 0. And you classify like a vertical hyperbola. Boom. Look at that. Center, vertex, foci, and reference rectangle. Okay, in the real life, the important point is vertex. Well, center is super important. Vertex, foci, of course, and the reference rectangle. You don't need to do well. You did in detail. I put here because it's the educational purpose. But in the real life, you determine only one. So from the center, you see this is A, this is A, this is B, and you plot that point. This is A, this is B. Not necessarily do the stupid reference rectangle. No, I am doing because I want to illustrate the idea. But I understand very well in one test, in one answer of the test, it's not strictly necessary to do the reference in detail. Okay, any question in the example 2?
Buscando. No veo ningún dispositivo al que pueda conectarme. Verifica el dispositivo que quieres usar y asegúrate de que el Bluetooth esté activado. Si quieres configurar otro dispositivo, abre la app de Alexa.
Do you hear Alexa?
Yes, we do.
Yeah, Alexa is crazy.
Perdón, no hay nada que repetir.
Okay, switching to the whiteboard. Okay, do you see whiteboard or no? Clear.
Yes.
Example 3 now. Well, example 3 is also a little bit complicated because in that case, I want to introduce the idea in which with example 3, the center is not in the origin 0, 0. But nice because it's giving a standard. Look, x minus 2 squared over 9 minus parentheses y minus 3 square equal 1. Okay, entonces maybe question number 1 is what kind of a hyperbola we have, vertical or horizontal? So in other words, our hyperbola look like that or look like that. This is horizontal, this is vertical, no? What do you think? And why? What is the reason, no? Nobody know? Nobody want to participate in this? No Isabela anymore.
No, never mind.
Well, no, see, nobody know, only Isabela. Isabela help me, no? Pero I want que another student participate. Mimi, do you know or you don't know? Gabriela, you know or you don't know? Of course, Carlos, I suppose you know very well.
Horizontal.
Absolutely. How do you know, Carlos?
The x side is positive.
Exactly. Okay, when I repeat, I suppose I repeat 4 times. You see, What is the term que es positive? Sx. So now that means que our transversal axis is parallel or coincident. In this case, parallel, because we have some motion, no? Some translation, some transformation. Okay, now the question number 1, horizontal hyperbola. Okay. HH, horizontal hyperbola. Okay. Okay, super. Now, next. Okay, what is it? Next. Next. Where is located the center of this hyperbola? Where is located the center of this? At what point is located the center of this hyperbola?
2,3.
2,3. Very well. 2,3 again. Remember, it's similar to the thing we studied before in circle and ellipse. So you see in the equation we have negative is because in the point is positive, no? Because in the point is negative, double negative become positive, and you see in the equation like a positive sign. 2,3 is excellent. And what about a squared and b squared? Who is a squared and who is b squared? Look in the equation. Look in this equation. Come on, I'm waiting for you.
Is A3 and B1?
And B1. Okay. And my question for a squared, but it's okay. It's 9 and 1. Therefore, a is 3. And b is 1. Okay. Now, determine the C. It's easy. C is square root a squared minus plus b squared. Entonces es square root. This is 9 plus 1 is 10. And the square root of 10 is decimal approximation, no? 3.162. Okay. Entonces now, in this case, a little bit more complicated to do by hand. Let's try to do something, but it's complicated because it's, well, okay. You plot the center first. 2,3. 1, 2. 1, 2, 3. This is my center. Okay, now A is 3. Is 3, but in that direction, parallel to the x-axis. So 1, 2, 3. 1, 2, 3. Actually, this is 5, no? Because 5, 2 plus 3 is 5, no? And 1, 2, 3 actually is -1, no? I guess so. Here. All right, 1, 2, 3. Okay, this is the vertex. So the vertex is located at the point 5,3. Sorry. This point, this point is a point 2,3, no? And the vertex is located at the point 5,3 and -1,3. Make sense? Guys, this is super easy. This is just geometry. You plot that, no equation. You don't need to memorize any equation. A stupid equation. This is you put A in that direction and A in that direction. And B, que B is 1. Entonces, our box, our famous reference rectangle look like that. Because B is 1. And the corner is this, and the asymptote is this, like that. After we determine the equation for this line. And our famous hyperbola, okay, by the way, horizontal, passing through the vertex and asymptotically to this line. Of course, guys, this is a smooth curve. Okay, no like that. Boom, boom. No. No. Okay, now. The focus is, here. Inside here, in the same transversal. This is the transversal axis. And this distance is 3 point something from the center. Entonces, es a weird number, right? It's 5 point something. Entonces, no 5 is a 5 point something. But let's see. Let's see. So, fuzzy. Is 5 point 162, comma 3, no? And in the opposite direction is negative 1.162, comma 3. Okay. But we completed. I recommend, and the problem is complicated with the numbers decimal, and we have translation to say we're using the decimals, no, to see more clear, right? Okay, let me see. Decimals now. Share. Okay, do you see decimals now? Yes or no?
Yes.
Example 3. Let me see if I copy or no. Well, example 3. Example 3, hyperbola. I copy well. This is our hyperbola. Oh, wow, look at that. Now determine the points using my script. Be careful. A is in this example 3, no? Yeah, and B is 1. But H and K. H is 2. And let's look at the point 2, 3, and K is 3. And that. Okay, now ready. Entonces you classify like a horizontal, no? Hyperbola. Boom. Look. Entonces you see a lot of details. You see center. You see vertex, foci, and the asymptote. I forgot the equation for the asymptote. Right now in the whiteboard. Okay. Do you see clear? Yes or no?
Yes.
Yes. Okay. Now. Whiteboard. Because I forgot the equation for the asymptote, no? But it's easy. Okay, remember that in general, I need to memorize that formula, no? Y minus K is equal plus or minus B over A X minus H, no? Because que our hyperbola es horizontal, ¿no? Entonces, cuando es horizontal es B over A. Entonces, and K es, Y minus 3 equal plus or minus, and B divided by A is 1/3. Remember, B is 1, A is 3, and X minus 2. And leave it like that. Remember, in elementary algebra, there are many ways to express the equation for the line. The most popular is slowness form. But we have another case, point slope. Case y minus y1 equals slope x minus x1. This is when you have slope is given. Actually, the slope is this. And 1 point. And the point we use it always as the center. The center is h, comma a. Do you see the analogy for this equation and this equation? Do you see? Yes or no?
Yes.
Any question in this problem number, example number 3? No? Okay, let's do one more. Of course, more complicated, in which you need to manipulate more because it's no nice. It's totally ugly. It's expressed not in standard, and you need to express it in standard. This is the typical you see in the test. Of course, in the test, I don't put elementary kinematic example. No, I put a complicated example. Example 4. Do you see what board, right? Yes or no?
Yes.
Let me know. Yeah, me know. Okay. Suppose this example. Suppose you have 11x squared minus 2y squared plus 66x minus 4y plus 75 equals 0. You say, wow, what the hell? It's confusing. No, no, it's not. Because it's a hyperbola. How do you know it's a hyperbola? Well, when you see in the equation, okay, x squared is present here, and y squared is present here, and it's minus in between somehow, look, minus, it is a hyperbola. The rest of the element in the equation represent the translation. And this is not standard. This is general form. In the general, you don't see anything about center, AB, I don't know. So you need to apply completed square. So what is the idea? Well, you group index, que es this and this, together. And you try to, when it's possible, of course, factor out something. In this case, 11 is a common factor. X squared plus 6x, right? Plus the box, the magic box that completes the square. Now, likewise, you grouping the y part. In this case, the common factor is minus 2, no? I guess so. Minus 2. We have y squared plus 2y plus another box. Do you understand the organization of the equation? So what about 75? Well, 75 moves to the right-hand side. And you have two boxes that guarantee me the equilibrium of the equation. Do you understand this organization?
Yes.
Yes. And remember one more time, I explained the formula for the completed square. You take 6 divided by 2 and square. Always is b over 2 squared. That's the formula for the completed square. 6 divided by 2 is 3, 3 squared is 9. 9 here. I suppose que another number equivalent in the other side. Que not necessarily is 9, because this 9 is inside the parentheses, and multiplied by 11 is 99. Do you see that? Yes or no? And what about this? 1 is 2 divided by 2, que es 1, square is 1. And this 2, this 1 is no 1, it's because 1 multiplied by negative 2 is negative 2, so we have negative 2 here. Okay, this equation is more nice. Okay. Now factorization. This trinomial is perfect square, and this trinomial is perfect square. I create artificially. Entonces 11x plus 3 square minus 2y plus 1 square equals something. Okay, 75 and 2 is 77. So 75 negative and 2 is 77. And 99 minus 77 is obviously 22. Subtracting, addition, 22. So far, everyone follow me or no? You are totally lost. Do you understand very well the thing I am doing or no? Because always is the same. Complete the square. Now we have already the equation standard. No. Remember, the standard is when you have something like that, x minus h square over a square maybe minus y minus k square over b square equal 1. That's important that the right hand side must be 1. So you divide by 22 whole thing. Okay, 22, 22, 22. Now, 22 divided by 11 is 2. So we have so far x plus 3 is square over 2 minus, and 22 divided by 2 is 11. Entonces y plus 1 square equal over 11 equal 1. Wow, nice. This is our nice standard equation. Entonces present standard form. Okay, super. Entonces, confirmation, ¿no? Confirmation now. What kind of the hyperbola we have? We have vertical or we have horizontal? So our hyperbola is like that or like that. Okay, answer me, pero no Isabela, no Carlos, another students. Do you understand this or no? Because I can explain 40 times for you. How you identification see our hyperbola is horizontal or vertical? Are you clear or confusing? Okay. Nobody know. Wow. You know something, guys? I want to teach one more time the class in person. Okay, I suppose que in the fall the college open everything in person like a normal, because I don't see your face, and you know, entonces super hard working this. Another class no, another class behave good. Okay, Isabella, help me. Carlos, help me. What kind of the hyperbola we have?
Horizontal.
Absolutely. Could you explain to the rest of the student why? The reason? What is the reason?
Because x plus 3 squared over 2 is positive, and that means that a is positive.
So, this is the positive part of the equation is associated with the x. This is x is horizontal. Okay, see, this the positive part is associated with the y. Suppose that I change the problem, and the problem now is different. It's not like that. It's supposed that I change. No, I don't want, but okay. Proposal to explain. This is minus, this is plus. This is completely different problem. Okay, in this case, our hyperbola is like that. The graph, no? It's vertical. Do you understand or no? Now you understand or no? Say something. Yes, no.
Yes.
Okay. Who is a square and b square in this example? Who is a square and b square in this example? Compare this equation and this equation. Nobody say? Who is a square and b square?
A squared is 2, b squared is 11.
11. Entonces now a and b is a weird number. Look, it's radical 2. And radical 11 is a prime number, and this is decimal approximation. This is too complicated doing the graph, but we're using the script of decimals. Okay, it's 1.414 and 3.316. Okay, so now what about center of this hyperbola? At what point is located the center of this hyperbola? At what point is the center of the hyperbola?
-3, -1.
-3, -1. Okay, this is H and K. Look, compare. It's obvious. One more time. Look, H is that number. Entonces es 3. No, because in the formula you see negative. The reason is because it's x minus 3. And double negative become positive. Actually, nobody showed this process, but you need to understand. Entonces, what tenemos que divide to remember that? Bueno, si you see in the equation que es positive, es because in the point is negative. Opposite sign. Are you clear? Bueno, the rest, let's do it. Bueno, okay. Let's do it in decimals, no? In decimals. Because the number is weird, complicated, decimal. Entonces, subtraction, addition, decimals, sometimes a little bit complicated, right? Okay, let me try. Okay, decimal now. Okay, we are doing example 4, no? Yeah. No 3 anymore, 4. 4 is this. Look, I copy in the script exactly the same number we have in the original problem. Look. Okay, this is our hyperbola. Okay. So we discover using the algebra part. Okay, A was radical 2, no? Yeah. So you put a decimal approximation. No, I recommend put the exact value using the keyboard of decimal que contains square root 2. Good. This is A, and B is square root 11, no? Square root 11. Wow. Square root 11. Guy, you see decimal, no? Right?
Yes.
And what about H and K? Well, H and K. H is negative 3, no? Negative 3. And K is negative 1. No? Let me know if I'm doing well because I don't see the whiteboard now. I am doing well. Negative 1. K is negative 1. Yeah. It's minus 3 and minus 1. Yeah. It's center. And you classify like a horizontal, no? Yeah. Boom. Look at that. Okay. Center. Vertex. Bosses. Asymptote. End story. Any questions? Good or not good? I promise we go over again to this in the review package. Okay, guys, we continue. The conic section. Now we continue to another section, another topic. Okay, it's about, we almost finished. Sequence. So we are talking. Do you see whiteboard or no? Yes or no?
Yes.
Yes. Thank you. Okay, this is sequence. Sequence, super easy. What is sequence? What definition? Well, a sequence is like a function, but in this case, the function, the domain is natural number to real number. Okay, the natural number means we start in 1, 2, 3, and so on. Natural number. No decimal, 1.5, 1.1, no. 1, 2, 3, 4, 5. And the real number, well, is continuous. Okay, forever. So now it's super easy. The notation for the sequence is I give you the explicit formula for the sequence. Okay, for example, it's given is A sub m. This is the notation that we are using. A sub n is equal n minus 1 divided by m. This is given in the problem, the formula. So I need to find, this is explicit formula of the A sub n. And A sub n represents any element in the sequence. So for example, A sub 1, here's the first guy, is 1 minus 1 divided by 1. 1 minus 1 is 0 over 1 is 0. A sub 1 is 0. A sub 2, evaluating 2 is 2 minus 1 divided by 2. Is 1/2. And so on. And so on. A sub 3 is 3 minus 1 over 3 is 2/3. Entonces, and the question say, well, compute the first 5 terms of the sequence. Okay, there's 0, comma 1/2, comma 2/3, comma, what is the next? Well, the next is 4. 4 minus 1 is 3 over 4. Because it's easier, according to the formula, you plug in m, but the numerator is less than 1, the numerator. Entonces, si n is 3, is 4, sorry, 4 minus 1 is 3. And what is the next? Well, the next is n equals 5 for 5th, and so on. Got it? This is super easy. The sequence. Now, some sequence is a little bit weird because, for example, we have, suppose this, the explicit formula for that sequence is A sub m is -1 raised to the n power times 1 over m. Oh, it's reciprocal. Suppose, forget about temporary. This guy is a complicated guy. And suppose that A sub m is 1 over n. Oh, it's easy. N equal 1 is 1, n equal 2 is 1/2, n equal 3 is 1/3, and so on. 1 over 4, bam, bam, bam. When you want to indicate something, okay, this continue forever, using the same partner, same formula, you put three dot, indicate that this is the continue forever, and the same part. But in this case, you include a -1. So this is the formula for the A sub m equal 1 over m. Suppose now I include -1, entonces it's the same value, but the sign is alternating. Why? Because suppose n equal 1, -1 raised to the -1 power is -1, so it's negative the first. And the second, no, n equal 2 is -1 squared positive, this is positive, and this is negative, and this is positive. And the positive not necessarily indicate. When you omit the sign, default, everyone understands it's positive. Okay? Well, I suppose, okay, I want completely different idea is A sub m is equal -1, pero m plus 1, 1 over m time multiplication. So it's exactly the same, but alternating in different way. In this case, the odd number, who is the odd number? 1, 2, no, 2 is even, 3 is negative, right? In this case, the even number is negative. It's the same value, 1, 1/2, 1/3, but I create artificially using n plus 1 exponent. N equal 1 is 1 plus 1 is 2, and square positive, so this guy is positive, it's a negative, this is positive, alternating. This is called guy alternating sequence. It's a sequence que have positive, negative, positive, negative, positive, negative, positive. And you see in the example when you study in detail sequence, that sometimes you classify, no, this sequence is alternating, this sequence is not alternating. Okay. This part is easy, eh? Okay, the mathematicians say que the istres topic in mathematical sequence. No, I totally agree, but it's okay. It's easy. Okay, let's start super important part in calculus. Inside the sequence. We continue sequence, but now we continue now summation notation. Summation notation. Super important. Okay, suppose that we have a sum of different quantities. Look, suppose that we have A1 plus A2 plus A3 plus A4 plus until and you finish A20. Okay. One way to express this, and only one condensing way, is using that symbol. And that symbol is a Greek letter. And the name of this letter is sigma. Sigma. Capital sigma. And you indicate here inside A sub k, you declare one variable. Okay, normally we using maybe the most common letter we using is MKIJ. It's an index variable. Index. And you declare that variable case k, in this case, go from k equal 1 to 20. Because 1 is the first and 20 is the last. Do you understand this one? Do you understand this one?
Yes.
Absolutely. Super. And we study in detail the property for the summation notation. I promise in calculus you're using that. Okay. So now let's practice a little bit easy problem, elementary problem of the summation notation. And little by little, I want to complicate your life. Look, suppose this example, sigma from k equal 1 to 5 of the 1 over k. And what's the job? Well, it's giving the problem in summation notation, and you have to expanding this summation notation. Okay, you evaluate the first case 1 is 1 over 1. The second is 1 over 2. You suppose that default the element is in between 1 and 5, including both endpoint, 1/3, 1/4, and 1/5. If you want, this one, case 1 over 1 is just 1. Clear the idea?
Yes.
Let's do in Bauer. Suppose this example in which you have the expanding and you condensing, so you write a sum like a summation notation. Suppose you have 1 square plus 2 square plus 3 square plus 4 square plus and you ending in 9 square. I need to write this summation, it's too long, and that notation. Entonces, I'm using the one index variable, using k, using I, and this is the first case 1, no? And the last is 9. And the mathematical expression is similar to the sequence. I try to find the expression of the a sub m. It's obvious que es n square. Okay, a sub n, and this sequence is n square. Because you divide, so n is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, and so on. Do you understand this? Summation notation? At least the basic idea, no? Okay. To advance, to continue in the summation notation, we need to study their property. So properties, important properties of summation notation. Okay, there you go. Okay, the first property is property 1. Is suppose that you have summation from k equal 1 to m. Okay, 1 is the first, n is the last. Of the one element is called a sub k, but you multiply by z. And who is z? Z is the number. What number? One, any real number. Okay, entonces now when you multiply, it's obvious that you can factor out like that. C out summation k1 to m of the a sub k. Do you understand that property? Now, suppose in one problem, no, in one problem I put solving that, and you have summation from k equal 1 to n to the phi n squared. Entonces, in the manipulation, you factor out this phi. This is perfectly legal. And it's a k, sorry, because the index variable que I declare is k. Don't confuse it. K, so in the bottom, you put the index variable, and n is no index variable. Suppose que es numerical value. So don't complicate your life. It's 20. Now here is 20. Entonces es k squared. And you focus in that part, you see the formulas to solve in that part, and finally multiplication by 5. Do you understand the idea of the property number 1? The property number 1 say, if you have a sequence, a sub k explicit formula, and you multiply by a number, and you put inside the summation notation, the constant you put outside. This is the name together with the property number 2 I want to study now is the idea that the summation notation is linear operator, A linear operator say que es the operator que apply inside the sequence, and it doesn't matter que you multiply by constant or no, because you put outside, or in the property number 2, let's see, what is the property number 2? Suppose k equal 1 again to m, and you have the sum or difference two sequences. So this is the argument of the summation notation. Now you can separate, it's obvious. You can separate like that. I put plus and minus because this is a properties fallacy, is addition or subtraction. Clear? This and this together. This and this together. It's obvious, no? This is no secret. It's when you consider linear operator. You separate in different pieces, and any constant you put outside the game. Okay, another property gets a little bit confusing, pero es using common sense. You can split if you want, and sometimes we need to split. Suppose that we have a sequence in summation notation, and you need a split into. And for example, you split from k equal 1, que is the beginning, to one specific number m. Okay, this m is a number in between 1 and m. And you continue the summation from k equal m plus 1 to m. Example, to understand this. Suppose that I have summation from k equal 1 to 100. You can split like summation to k equal 1 to 80 plus summation from 81 to 100. And you say, well, professor, what is the reason I need to do this? Well, you see now after. But it's possible, right? Split. And I assume 80, pero doesn't matter, 50. Si suppose que adding the first 50 number, you start the second summation for 51, no? To 100. Do you understand the idea? Yes or no?
Yes. Yes.
It's elementary. Okay, come on. Speak. Isabella always has me. Okay, another formula. Property number 4, we have different property. Property number 4. Suppose we have summation from k equal 1 to m of the one number, C. C is a number, 20, 40, 100. Well, this is easy. It's just multiplication and C. One example to understand this. Suppose you have summation from k equal 1 to m to 5 of 20, for example. This is equivalent to say 20 plus 20 plus 20 plus 20 plus 25 times, no? 1, 2, 3, 4, 5. Okay, by the way, it's 100, no? And you get the same answer if you multiply this times this. This is the idea for the property number 4. So when inside the summation, we have a constant, no variable. Entonces now you multiply, and that's it. Multiply who? Multiply the number times the upper limit of the summation. Makes sense or no? It's clear my explanation, it's confusing my explanation. You understand? You don't understand anything, or you understand very well?
It's clear.
That's clear. Okay, property 5. Ooh, property 5. Property 5 is summation from k equal 1 to m of k. Ooh, what is that? Look, you adding 1 plus 2 plus 3 plus 4 plus that to m. And we have one specific formula. And Gauss is the most famous mathematician in the history. Gauss. When I was a student in elementary school, the teacher put that problem. Look, adding 1 plus 2 plus 3 plus plus 97, 98, 99 to 100. Get the answer of this. And Gauss solving this problem in 1 second. Gauss do not the formula like I want to explain now. However, Gauss doing different to another student. The regular student doing it that way. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. No, Gauss doing it that way. Gauss adding 1 and 100 is 101, no? Wow. So you adding 1 plus 100, so the first and the last is 101. The second gets 2 plus the next que es 99, no? This is the same value. Bam, bam, bam. And this idea is repeated 50 times. How do you know get 50 times? Because we have 100 number and we have 50 couple. So basically multiplication 105 times 50 is 5050. And Gauss doing it that way. So you generalize, not in 100, you know, any value, the formula is m times n plus 1 divided by 2. Do you see? The n plus 1 is, in our specific example, 101, and n divided by 2 is 50, because it's 100 divided by 2. Do you see that? So nobody doing by hand this, no. You apply the formula. In calculus, you need to do summation of the different thing, and never we are using the regular summation. No, we're using the formulas. This formula, property number 5, property number 6, and property number 7. Summation when you have, for example, k equal 1 to m of the k square, and property number 7, k summation k equal 1 to n of the k cubic, and that's it. And the formula, well, this is 1 squared, 2 squared, and so on, no? 3 squared, plus to n squared, and the formula is different. The formula is n plus 1 to n plus 1 divided by 6. And maybe you say, well, professor, where I come from this? I want to prove this, but no now. In the other section, I want to prove every formula using one special mathematical tools. But no now. You are set down, and we're using in the problem, no? This is 1 cubic, 2 cubic, 3 cubic, plus plus n cubic. And the formula is a little bit weird. It's n squared, n plus 1 squared divided by 4. By the way, unbelievable, but it's true. It's the same formula of this. Same formula of this, but a square. Okay, it's n plus 1 divided by 2, well, it's square. Okay. Now let's practice the 7th property of the summation notation. So far, any question? You clarify in the example now, okay? I promise. Okay, example 1. Example 1, compute. So this is typical, the question K1 to. Example 1 is compute. Summation K1 to 5 of the parenthesis 3K. You see, wow, we have a constant. You put a constant outside. And you have K now alone. And this is the formula. The formula say is 3 times, don't forget this 3K factor out, and you apply the formula. The formula say is 5, que K, or M, multiplied by n plus 1, que is 6, divided by 2. Okay, that's a 45. Because 30 divided by 2 is 15, 15 times 3, 45. Well, the same answer we get if you, for example, you evaluate for k equal 1. K equal 1 is 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. This is 3, this is 6, this is 9, this is 12, and this is 15. And you get 45. But this is oh no, professor, it's easier that way because I don't need to memorize that formula. Okay, however, see, I put here 500. So who is easy? Doing the formula or using in the expanding form? No. Okay, got it? You understand the example number 1? Okay, let's do example number 2. Example number 2 is summation.
Professor. Sorry, why did you multiply by 6 again? 5 times.
Good question. Because the formula es Isabela, no?
Yes.
Isabela,
Yes.
Isabela, the formula is n plus 1 divided by 2. Who is m in my problem? 5. 5 plus 1 is 6. Got it?
Yes, thank you.
Okay. Suppose example 2. An example 2 is k equal 1 to 20. 20 is not too much, but it's of the 5k plus 3. Compute that. Well, now I take advantage the property of the linear operator, and you put a 5 outside. Why not? And you split into summation. 5 summation k equal 1 to 20 of k, plus another summation from k equal 1 to 20 of 3. Okay, do you understand the thing? I apply the property, and the property operator I split in two summation, no in one, and the 5 gets a constant I put outside again. Now it's super easy to compute that, because the 5 multiplied by the formula is 20 times 21 divided by 2. The formula, repeat again the formula, n plus 1 divided by 2. Who is n? Is 20. 20 plus 20 times, no plus, times 21 divided by 2. Entonces, in this case, no formula. No, because the formula F1 is only k. And it's no k, it's a constant. And the constant exists, it's just a multiplication, que es 20 times 3. Do you see that? Okay, I compute that part. The answer is 1050. I compute that part, que es 60. And the answer is 1110. Boom. Do you follow me? Do you follow me?
Yes.
Excellent. Okay, I put another example, example 3. And example 3, I bring extra complication. Sigma from K0 to 14 of the expression K is equal to that K squared minus 4. What is the extra complication? Well, so far, the only problem that we are doing, the index variable starting 1, not in 0, never starting 0. So the formulas that we have in my hand is not valid when it's 0. It's valid when, but it's easy because I split into, for example, I split for k equals 0 is 0 squared minus 4 plus, and the rest is summation from k1 to 14 of a k squared minus 4. Do you understand the thing I'm doing? Okay, the formulas que we study in their other property here, property 5, 6, and 7 is under the supposition that we start in 1. See, we start in another number, no, it's not valid. Let's see how we solve it. I present the first example, que start in 0. And this is easy solving because I put outside 0. So I split my summation notation in 2 pieces, but one piece is easy, it's 0, only 0 at k equals 0, and the other is star and the rest, 1, 2, 3, 4, 5, until 14. Makes sense, right? Now that part is -4. And that part, well, I split into part, summation, summation from k equal 1 to 14 of the k squared, minus another summation, if you want, k1 to 14 of -4. No, actually it's 4, no? Because this negative, I put it like a. Okay, super. Now, this is -4. This is another formula. What formula? That formula. Look, let me show you. That formula. The formula property number 6 we use now. Okay? And the formula say m n14 in our example 14 plus 14. N plus 1 que es 15. And 2n plus 1 que es 28 plus 1, 29. Divided by 6. Do you understand where I come from, 15 and 29? Let me copy one more time. The formula is, look at the formula, that formula. But I want to copy close to this. It's n plus 1, 2n plus 1, divided by 6. For n equal 14, this guy is 14, this guy is 15, and this guy is 29. Make sense, right?
Yes. Yes.
Now minus something. Oh, but here we have a constant. I know that the constant, you don't need to do anything, only multiplication. 14 times 4. End the story. Okay? So we have negative 4 plus, doing that operation with the calculator, you put 14 times 15 times 29 divided by 6 is 1050 minus 64, right? 64, yeah, 64. And the total answer after you subtracting this 64 plus 4 is 68, subtracting 1015, the answer is 955. Is the final answer. Do you follow me, guy? This is the first test. Very well, very well. Who say that? Say your name. Okay. Let's compute it now. More complicated. We continue doing example of the summation notation, guys. Example, what we're doing, 1, 2, 3, no? Example 4 now. Example 4. Suppose now compute that. Sigma from k equal 10 to 20. No, to 60. Wow. Not 20, 60. Of the one expression que es just 2k. Okay, it's easy. Let's focus on this. Okay, this is equivalent to say, bueno, it's a constant, 2 is a constant, I put outside the summation symbol. But in this case, we cannot apply formula because my formula, the supposition, the assumption starting 1. So that formula is n plus 1 divided by 2. So I need to split. Look how we are doing that. When we are doing like that, look, let me show you. There are 2, I put outside the game. And you split this summation in 2 summation. This summation and another summation. But this summation is starting 1 to 60. And subtracting that summation is starting 1 and ending in 9. Wow. Let me show you. I want one summation to starting 10 and ending in 60. But I have no formula for this. I have formula summation que starting 1 to 60 y starting 1 to 9. In order to find this, you compute this and subtracting this, and we get that. Do you understand this or no? Do you follow me? Completely lost? Completely lost?
Is it 9 because of the k?
Let me show you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Our summation, okay, I want to compute starting 10 to 60, right? However, we have no formula for this. No formula. The formula that we have in my hand start always in 1. Therefore, I propose the following idea. You compute from 1 to 60 and subtracting That part. And you get the green part. Make sense?
Yes, yes.
Excellent. Excellent. Okay, that's that split. I have formula for this. So I have formula always que we start in 1 to any number. Never 10 or another arbitrary number. So the formula is super easy. You multiply 2 bracket, and you compute that like a 60 times 61 divided by 2. I suppose that everyone understand where come from 61, no?
Yes,
Yes. Yeah. And 9 times 10 divided by 2. Super. Put in the calculator maybe. And this is 1,830 minus 45. Because it's 90 divided by 2, no? Entonces now subtraction, multiplication by 2, 3,507. Boom. Final answer. Okay, entonces now when my summation, no, do not start in 1, you need to create one artificially idea, right? One more example, and that's it. Enough. We continue next time. Suppose example 5, and end the story. Example 5 is compute the summation from k equal 4 to 24 of the k cubic. Uy, k cubic, what formula? K cubic is that formula. Let me see that formula. K cubic. K cube. Okay. But this formula you apply when you start in 1, not in 4. But okay. Entonces I'm doing that way. Look, I immediately say that this is equivalent to say starting 1, okay, I know the formula, to 24, and subtracting the part I don't want, que is starting 1 to 3 of k cubed. Okay, now using the formula. The formula say, let me use the formula in that way. Look, m plus 1 similar to the formula for the k per square. In my opinion, the easy way to memorize that formula. So actually it's 24 multiplication by 25 divided by 2 square minus 3 times 4 divided by 2 square. Okay, this is 300 on the calculator, of course, and this is 6 because 3 times 4 is 6 times 2 square is 36. Oh, it's square, sorry. 300 square. And this is 6 square. Okay, 36. The answer is 89,964. Okay. One more. The last one. Okay, let me erase the bar. Let me ask something. Do you copy? When I teach in this, you copy, or you copy after when you see the video, or you never copy? Answer me. Because I normally in the regular class in person, I teach in the whiteboard, in the physical whiteboard, and student copy in the notebook. No? Now, what is the way that you are doing in these virtual classes? You copy in notebook or you don't copy? Answer me. Isabella copy, Carlos copy, and the rest?
Yeah.
David copy. One more copy. No. Either way, guy, I copy in my notebook, say Jasmine. No say, I don't know. It's the regular habit in the school that you bring notebook and you copy, no? And to say, well, you copy. See, you don't write, I don't understand. So some people say, no, see, I don't write, I don't understand. See, I write, I understand. This is the visual. technique, right? You see, wow, you copy something to say, maybe, I partially understand. Okay, one more example, and that's it. Sure, that one. Suppose sigma K20 to 50 of 80. Okay, entonces this is easy because it's a constant, ¿no? It's a constant, entonces the professor explained when there's a constant, you multiply this number times this, no? But be careful. This situation happens when the K is 1. So for sure, you understand that, for example, so you have K equal 1 to 50 of the number K constant, so you multiply 50 times 80. Okay, by the way, but F50 or F50, yeah, 50. Suppose to understand much better. Suppose que it's not 50, F5. Actually is, you know very well, que F5 times 80, 400, huh? Why? Because it's 80 plus 80 plus 80 plus 80 plus 80 5 times, huh? It's equivalent to say 5 times. It is classical, it's clear. Suppose to complicate a little bit your life. Suppose sigma, pero K3 to 5. Well, I have no formula. Maybe it's multiplication. No, it's impossible. Because actually we have no 5. How many 80 we have? When we have for K equal 3, 1, for K equal 4, another, and for K equal 5, another. So actually we have 3. Okay, it's 240, no? 240. So basically you multiply 80 times 3. And where come from this 3? What is the formula I try to generate to find the 3? Well, so you're subtracting 5 minus 3 is 2. Entonces plus 1. Because the idea is clear. Is what is the number between 3 and 5, including both endpoints? Is 3, 4, and 5. If you apply this idea in this example, well, let me show you. Okay, we have 80 multiplied by something, and something is 50 minus 20 plus 1, including 1 extra. Okay? The 30 is 31, so it's 80 times 31. The answer is 2,480. Do you understand this or no? Entonces mechanical. Okay, bueno. Okay, I understand. However, what is the reason that when it's 1, you don't need to add in 1? Because it's, look, suppose que es 1, entonces es, you're using the formula, you say 80, es 50. Suppose que K is 1 now. How many terms? 50, 50. Entonces, because it's 1 plus 1, not necessarily 1 in this case, no? Because it's 20. Where come from this 50? I don't understand. It's sí, suppose que es 1. Es 50 minus 1 plus 1. 1 plus 1. This 1 is this. And 1 plus 1 is cancelled. That is the reason I multiply directly that number and that number. Okay, guys, stop here. I continue next time. I reinforcing this idea. Okay, it's a little bit weird. And Thursday we can see. We continue. Okay. So now I want to say goodbye. let's see, 30. Okay? Bye-bye.
Bye, Professor.
Have a nice day.